is a classification technique. So suppose you are given two fruits, say one is apple and another one is orange. So how you will distinguish those fruits? So this is an apple and this is an orange. So can anyone say? So by our human cognition, human mind. So this is, say, suppose your apple, and say this is your orange. So how you will distinguish these two fruits? Anyone? So this talk will be little interactive. So please try to interact with me. Okay. So what comes in our mind? Say okay, maybe say food color. Say one feature or one characteristics comes to your mind. Okay, some red thing, it is some sort of apple, and some orange, maybe it is the color is say orange, and another maybe say shape. Okay, so by our human mind, okay, this two, like by looking into the outer loop, so we can think, okay, using these two characteristics I can distinguish. So in machine learning domain, we call this as a terminology, say we call this as a, say, features. Okay, so I have two features. So one is a color and another one is shape. And but it may so happen that you need to look multiple apples, multiple oranges. So what we will do, I will take multiple samples. Here I am given say only one samples, but I have to take multiple samples. Okay. So our brain will look upon multiple samples. So one set of sample will say train, or suppose think in this way, you are training one child. Okay, so one very small child, you are training him. Okay, this is apple and this is orange. So you will show him some apples image or some oranges image or some real fruit. Okay, so that when you are training that child, we are calling this as a training phase. After that, okay, I am testing or say taking some exam. So some unknown fruit or unknown shape of orange, I am showing you, and I am testing that child. Okay, he or she is able to understand this fruit shape or not. Okay. So this basic problem statement is clear, everyone. So in machine learning terminology, we have understood a few terminologies. One is say features, another one is say samples, and some more terminologies, that is training and test. Okay. So let's come into the convolutional neural network now, or before proceeding to that. Okay. So one very brief, the neural network. Okay. So in neural network, what we do, we have few layers. Okay, so this is, say, suppose one is the input layer, and suppose this one is the output layer. Okay, so the example we took, so we had only two features. So one is a shape and another one is color. So for that I am taking two features. So this like circular shape, we are calling this as a neuron. So one neuron in the input layer denotes say one feature, say feature one, and this one is the say let's write in this one. So this is say sorry, this one say x1 and this is say x2. So input feature. So after that I am adding one another layer. This we call as hidden layer. There are also possible multiple nodes are there. So these all things are connected. Okay. After that, I put an output layer. Okay. So I will distinguish that. Okay. So in the output layer, I may have. So here we are distinguishing or classifying apples versus oranges. So we will have two classes. This will denote say for apple class, and this will denote say orange class. Okay. So this will be also connected. So this is one basic architecture of a neural network. And here if we formulate this in this hidden layer, so what we will do, say this x1 x2, and I have to learn few weight parameter. So these weights, I am denoting this using say w. So here in this layer it will be, so at first it will be z equal to wx. So x is the combination of this x1 and x2. So x I can write say x1 x2, okay, plus some bias term, say b. So this is the, we call this as a linear combination of these weights and input features and some bias terminologies. And after that we will add some activation function. So activation function, why we use this? To capture the non-linearity. So suppose in a feature space, suppose we have say this tick symbol is for say apple and this cross is for say oranges. So we can linearly separate these two things. But in a higher dimensional, or if we have say multiple classes, it is not possible that, it may not be possible that we can distinguish those classes using some say by linear separation boundary. Okay? So for that we will add some non-linear activation function. So here what we will do, we will do say g of z. So g will be your activation function. After that I am getting this a. So here if we think this hidden layer as a big circle, so at first this will be your z. So z will be your wx plus b, and after that it will be a will be z of z. So there are few activation functions. For example, say in second half I will show you few activation functions. Say for example, say ReLU. Okay. So ReLU is rectified linear unit. I am not going into detail of this type of thing. So my major target is to teach you or to show you few things on convolutional neural network. These are some say background things. So after that, it will go in this layer. Here we will use say softmax. One softmax function we will use. What it will do? It will so after that in these two nodes we will get some probabilistic value, and this softmax will try to distinguish this probabilistic value or give some higher margin to those probabilistic values. And then we will calculate some also some loss function. So loss function, what we will do? Loss, it is some function of actual minus predicted value. So if suppose if I am taking say squared loss, so if y is your say actual class, say means like say, so in our example y is either 0 or 1. So 0 means it is apple class and 1 means orange class. So this will be y minus y hat. Say I am taking say squared loss. So squared loss, and there are other laws as well, half squared error loss, or you may use say absolute error. And after that, when you are taking the average over all the samples, so suppose you are given say 100 training samples, so you will average it down and you will get the overall cost. So cost will be, so sum over whatever you have calculated this loss, sum over this loss. Okay. The average of this sum over this loss. Yeah. Okay. So now, why we need to learn this convolutional neural network? So there are few things why we need to learn. So in earlier days, say before say 2012 era, mostly people use some handcrafted features. Okay, so handcrafted feature, what it is? Just I mentioned over here. So this thing. So at first you need to check the color, then shape, and suppose some people are taking say different features, say the age, the age of these fruits, or say maybe you have some matrix of say samples of say 100 samples of apples and their weights. Okay. So this we call say handcrafted feature, and few sophisticated handcrafted features are there. Say for example, say hog, so histogram of oriented gradient. So these features also they were used in earlier days. But in 2012, so one famous paper came, that is AlexNet. So after that, this computer vision or image processing domain has changed quite a lot. Okay. And but this invented this architecture convolutional neural network, this back propagation concept. This back propagation came around near say 80s, but convolutional neural network that came with one scientist, that is Lekun and his group, that was around say 1995 and 1996. But this requires a high computational power. So that time also it was not that much popular due to the limitation of the computational power. But after 2012, it just boomed. Okay. So we now focus on the convolutional neural network. So convolutional neural network, in short, we will call as CNN. So before knowing the total architecture, we need to learn few operations. So, as you can understand, obviously one terminology will be convolution. So convolution operation we need to learn. Okay. So what is that? Up to this clear with everyone? Very basic things I have told. Okay. So before going into this, I will tell you few basics. Say suppose no. Suppose this is a suppose this is a say some drawing, some the shape. Okay. If we want to detect the vertical edges, so which edges you will get? So for the vertical edges, so you will get this, this. Okay. And if you want to detect the horizontal edge, so you will get horizontal edge, this line, and these two lines. Okay. So can we crane is edges. So is it possible? We need to know. Okay. So in earlier days, there was some popular techniques of detecting these edges, was a Sobel operator and a Sharp operator. There we were using some kernels. Okay. So, but in convolution operation, we will train a model that will learn automatically those weights, that's kernel function. It will learn. Okay. So that is our object. Okay. Suppose you are given, so okay, so an image is nothing but a you can think of it as a matrix. Okay. So from 0 to 255 value, it will have 0 to 255 value and a matrix. So suppose you are given one image, so suppose something, so if we convert it into a it's a data matrix. It is nothing but a data matrix. So here, suppose this is the background portion. So here, suppose it will be 0. Here, some say age is there. Some values are say 10. Here, some values you will get say 20. So the values in this matrix ranges from 0 to 255. Okay. So similarly, I am taking one say data matrix. So it represents one image. So suppose I am taking one data matrix, that is 301274. after that, some values are there. Say 4, 6 to 8, and say 2, 4, 5, 2, 3. Okay. Some arbitrary values I have taken. So, what is the size of this matrix? Anyone? Hello. Am I audible to everyone? Am I audible?
Yes, sir.
Yes, no.
Okay. So this size of a matrix, or you can think of an image, this is a 6 cross 6. Okay. Now our objective is to show you a convolutional operation. For convolution, I am taking a 3 cross 3 filter. If I am taking 3 cross 3 filter, say now for now I am taking this as a say 1 1 1 0 0 0 minus 1 minus 1 1, and this star is we are calling this as a say convolution operation. Convolution operation. Okay. So what I will get? So look carefully how I am calculating. Okay. So this 3 cross 3 filter. So think of I am multiplying with this box. Okay. This green color box. So what I will get? Say this 3 into this 1, then plus 0 into this 0, 0 into 0, then plus this 1 into minus 1, 1 into say minus 1, then this again 1 into this 1, similarly say 5 into this 0, then again 8 into minus 1. Anyone please calculate? 2 into 1 plus 7 into 0 plus 2 into minus 1. So what will be the result? Say this 0 into 0, 5 into 0, 7 into 0, I am deleting. Okay. So now this is 3 into 1, 3, then minus 1, then 1, plus 1. So this is cancelling out. So this is minus 8, this plus 2, then minus 2. So this is also cancelling out. So 3 minus 8, I am getting say minus 5. So look carefully, this green color box, from this green color box convoluting with 3 cross 3 filter, I am getting one value, that is minus 5. Okay. Now what I will do, I will slide this window one position. Okay. So now this red color box, so again you will perform the same operation, say 0 into 1, then say 1 into 0, 2 into minus 1, then plus say 5 into 1, 8 into 0, 9 into minus 1. Similarly, you will get the next value. Okay. So can anyone calculate what you will get? So I have already calculated for saving some time. So okay, minus 5, this I will get say minus 4. Okay. So then again, if I slide one position, so this blue color, this box into convoluting this 3 cross 3, I will get 0. And the last one, okay, this yellow color box 274931513, this I am convoluting with 101 10 minus 1, 10 minus 1, and 10 minus 1. I will get the value 8. Okay. So Similarly, like row wise, I have got this horizontally. I have got this one. So similarly, for others, like vertically, I will also slide say this position. Okay, so this can you see like this position will also give this value. This will give me say -10. So let's fill it up quickly. So you can calculate by yourself in this way. So when we will write the program, so we like automatically we can calculate. Manually we don't have to, obviously. -16. Okay. So 6 cross 6 image convoluting with 3 cross 3 filter, I am getting a 4 cross 4. 4 cross 4 image. So this is some sort of representation of this entire image 6 cross 6 after this convolution operation. So if we perform say multiple convolution operation one after another, so in short how I can write? So you have this 6 cross 6, I have performed one convolution operation, I have got this 4 cross 4. So this convolution I have used the filter in short I am writing F is your 3 cross 3. So in some book or some blogs, you can see this type of diagrams, okay. But the internal, how we are calculating is this, okay. And we will use TensorFlow, so there we will use say conv2d. So if we import say TensorFlow tf dot nn dot say conv2d, if we write this way, we can perform this operation quickly. Okay? So, say quickly we'll see some other matrices, or you can take other examples also. Let's see some more examples. Okay. So, can anyone tell me that this position I am circling it out, this 3. So after using this convolution operation, this top left position, how much time this is coming over here, like contributing how much time? So let me clarify. So look this 3 and this 5, okay, this and this. So this top left one, this is contributing how many times? Only calculating this position. But this 5, this is used to calculate this -5, then next position also this -4, and say for this one also calculating -10, for calculating -2 as well. So everyone is getting what I am trying to say. Any confusion with anyone? Hello? Please interact with me. So what I am trying to say, this 3. So or you can think of these boundary positions. These are used say fewer times than the like say in the middle positions or the inner positions values. Is it clear with everyone? So if we think of this 3 is only used to calculate this -5, but this 5 it is used to calculate this -5, this -4, this -10, this -2. That means if we increase say this outer or say boundary of this image, or in convolution neural network terminology, if we add some pad, so here, or this technique we call say padding. So if we just add few, say some zero values or one values, anything, so we are extending the boundary so that this three can be used say more than once or multiple times. Okay. So this is optional. You can use or not use based on your say application. So sometimes it may work well, sometimes not. So so if we use this padding, so and fill this say zero padding. Say I am filling this 0 0 everywhere. So what will be the size of this input matrix now? Previously it was 6 cross 6. Now what will be the size? 8 cross 8, right? So left position I am increasing 1, in right I am increasing 1. Okay. So what I am trying to do, I want to formulate this uh, formulate so that based on the input side I can calculate what will be the output side. So here it is 6 cross 6, here now it is 4 cross 4, but suppose you are given say another dimension image, so you can easily calculate what will be the output side, either it is 4 cross 4 or say 5 cross 5, what will be. So for that there is a small formula. So if you have, if you can think of, you can understand how this formula comes, but due to the shortage of time I'm not going, I can't go very much detail. So if you have one image size say n cross n, so output will be n plus 2p minus f by s, so it is the floor into the same size, the same n plus, sorry, here will be 1 plus 1. Okay. So n plus, or better I should write in this way. Just n cross n, you will get say m cross m, so floor. Okay. Because if floor means like if you get say value say 2.71, the floor will be equal to 2. Okay. So that's the thing. So what is your m? M is your n plus 2p minus f by s plus 1. Okay. So this is your value of m. So here in this previous example, p is your this padding width is your 1. So if we take say p equal to 1, and here s is stride, I will come to this. So for here s equal to 1, s means like stride means how much I am sliding the window. So at first this box, then one position I am shifting, I am taking the next 3 cross 3 and sliding another position, one position only. So then taking this one, so sliding one box only. So that is your stride. So here if we put this, and f is your here 3 cross 3 means here f equal to 3. If we put this value, and n was your what, 6. So m will be your 6 plus 2 into 1 minus 3 by s was your 1 plus 1. Okay. So this will be your, what is the value? You please calculate. So 6 plus 2 minus 3. So 8 minus 3, then plus 1. Oh, okay. Here here for this example I did not use any padding. Okay, so for that p was 0. Okay, so 6 plus 6 minus 3, sorry, 6 minus 3 plus 1, it will be 3 plus 1 equal to 4. But suppose if I used padding, then p equal to 1. So if p equal to 1, then it will be m equal to 6 plus 2 into 1, say minus 3 by 1 plus 1, if you just calculate by yourself. Okay. So there is two type of convolution. One we called as valid and another is same. Okay. So same means when the input and output size are the same. So suppose we are using say 6 cross 6 and perform some convolution operation, also I am getting 6 cross 6. How I can get? Using the padding. So in the same, we always use some padding, and in valid, we don't use any padding. In the first case, we did not use any padding. That's why I am getting 6 cross 6 and output was 4 cross 4. But suppose I want to get say output also 6 cross 6. So then what will be the case? So n equal to will be say n plus 2p minus f by s plus 1. So for s I used 1, so n cancel out, so 2p minus f plus 1 equal to 0. So what will be the value of p? Anyone? So it will be f minus 1 by 2. Okay, so f I have used 3 cross 3. So if I put this value 3 minus 1 by 2, it will be 1. So if I use say padding only 1, so then I can perform this same operation, this same convolution. So this is the types of convolution. The convolution operation is clear with everyone. And regarding this s, so that we should mention over here, this image seems little dirty. Okay, just bear with me. So suppose previously I took this box. Okay, so now if I slide 2 positions, so next will be what I am getting, this one. Okay, so I have strided 2 positions. So here stride equal to 2. In this way we can perform. Clear? So now few more, another operation, say pooling operation. So operation is pooling or pool operation. So suppose you are given one say, so let's take some example. Okay, just a minute. I think it is visible to everyone. So suppose you are given say 4 cross 4 matrix. Okay, so here the values I am putting 1 3 2 9 2 1 1 1, and then 1 3 5 6 2 3 1 2. So this 4 cross 4 you just think of in this way. So this is a red box. So inside this red box, which one is the maximum value? Suppose I am performing max pool operation. So which one is the maximum among 1 3 2 9? Obviously 9. This 9. So I am putting this 9. So now think of this cyan or blue color box. So which one is the maximum? 2. Okay. But suppose you have say this position is also 2. So okay, max of 2 comma 2 comma 1 comma 1, obviously the 2 is the maximum. This yellow color box, the maximum one is 6, and this green color box, maximum is say 3. So I am done. So this from this 4 cross 4, I am getting 2 cross 2. Okay, this is your max pool operation. And similarly, you can perform the average pool operation. In average pool, what we will do? From this box, we will calculate say 1 plus 3 plus 2 plus 9 divided by 4. Okay, I will put here that value. Similarly, average out this 2 plus 2 plus 1 plus 1, then the average value I will put here. Okay, clear? So now I have shown you in a 2D image. So where I have only height and width. But it may so happen, you're obviously most of the cases it will be you will have RGB image. So red, green, blue channel. So actually you will have this one channel, sorry, this R channel, then this green channel, then you will have this blue channel. Okay, after that you will perform some convolution operation and you will get some say matrix. Okay, so how we will perform? So this you can think of a say volume, convolutions over volumes. So this, if I give heading say convolution over volumes, so how you will perform this operation? Can anyone tell? Okay. So for that, previously, say suppose I had say previous example I had 6 cross 6 image. Now I have 6 cross 6 into 3. Previously for the filter also I had this 3 cross 3. Now obviously I have this 3 cross 3 cross 3 because I have to match this 3 and this 3. Look carefully this step little. Okay. So I am performing the convolutional operation. So how I will perform this convolutional operation? Any idea with anyone? So what will be the output size over here? So previously I had 4 cross 4. Now my question is, now what will be the output size? 4 cross 4 or 4 cross 4 cross 3? So what will be the output size? 4 cross 4 or 4 cross 4 cross 3? Can anyone tell? Hello? Hello, am I properly audible or not?
Yes.
Okay, what will be the output size? 4 cross 4 or 4 cross 4 cross 3? Okay. So it will be 4 cross 4. Okay, so how? That we need to know. Look little carefully. Okay, so you have this 3 cross 3 9 values over here. Okay, so in this R channel also you have say 9 values. So these 9 values into 9 values you are adding up. So what I have add up, that I have already calculated over here. So I deleted them. Suppose you remember, perhaps you remember in here I wrote that one. Okay. So how I calculated? this point into this point, this, then this point into this point, this. So I have added it up. So that means I added up how much values? 9 values. Then for the green channel also, I will add up, multiply these 9 values and these 9 values in this green channel and add it up over here. So 9 values. Here also in the red channel I had 9 values. Look carefully. Then blue channel also I have 9 values. Okay. And here also in the kernel I have 9 values. So I will also multiply and add it up, 9 values. Okay. So after that, these 27 values, 9 plus 9 plus 9, I will add it up and overall I will get some value, say A. So this A I will put over here, only single value. Okay. So previously what I was doing? Only taking this 9 value and putting over here. Now because I have multiple channels, I am just calculating all these things and adding this up. For R channel, for G channel, for B channel, and all overall I am putting over here. So I am not increasing the channel. I am keeping it as it is, say 4 cross 4. Okay. Clear, everyone? So these kernel values, whatever I have, say 3 cross 3 into 3, these 27 values I am learning. This we call as a learning parameters. So in machine learning or deep learning, so if anyone is saying, okay, here is some learning is performed or learning is done, so what we are learning? So in interview or in somewhere you may face this type of question. So here we are learning these parameters, these values inside this kernel or the inside these filters. Okay. So here, this one are actually say W1, W2 up to here W9. In the second position, say W10 to say W18. And again here W19 to W27. So you have this W1 to W27. These 27 values you are learning. Plus one bias term is there. Okay, so that 28 values you are learning. Clear? Anyone having any doubt? So this you can think of say one volume. So this is say we call as a volume. Convolution over volume, still we are getting one single value. Now you can perhaps see, so this 27 values is for only say one say filter. Okay, number of filter I have used say here 1. So this is say filter 1. Now I can use say multiple filters. Say then what I will do, again I am using another filter. So this is my filter 2. Everyone please see or watch carefully. This is my filter 1. I have calculated this W1 to W27. Then I am using say F2. Now I have say W28 to W54, these values. For this also I will get another 4 cross 4 matrix, right? Another 4 cross 4 matrix I will get. So that means what we are getting, just a minute. So input, this step is little important. Input I had 6 cross 6 cross 3. Now I have used 2 filters, say 3 cross 3 cross 3, this size 2 filter, that is filter 1 and filter 2, that means into 2 I am convoluting this. I am getting 4 cross 4 into 2. Okay. Clear everyone? Any doubt? So I will repeat again. So here 6 is your n, means like image size. N cross this 3 is your number of channel. We call say denotation. We denote this using NC. So this will be, this 3 will be also your NC. This and this should be same. Okay. And this is your filter size, F cross F. And this 2 is your say number of filter. So what I will write this NF. So this NF and this should be same, this NF. Okay. And here this 4 is actually your output, output size, M cross N cross 2. Any doubt with anyone in this stage? So one set of convolution over volume and the pooling operation we have learned. Okay. So what we will do in real convolution neural network. So we have done this. We have one image. We have performed say one convolution operation. Then I am getting say it was say n cross n. Say here I am getting m1 cross ma1. So then suppose I am performing so one pooling operation. So size will be say, if I use a max pool, it will be say m1 by 2 cross m1 by 2. Then again I will use some convolution operation. I will get some size say m2 cross m2. Then I will use some say pooling operation. I will get say m2 by 2 cross m2 by 2. Then suppose I will get say values, say this was, suppose this was a 32 cross 32 image size. After that, suppose after this stage I am getting say this is 4 cross 4. 4 cross 4 means what? 16 values. So then I will get this, I will flatten, this called flatten. So I have this 16 value, 16 cross 1. From 4 cross 4, I am flattening this thing. I am getting 16 cross 1. So if you flatten this 32 cross 32, so this is a big number. But suppose you have one image type say 100 cross 100, so it will be say 100 cross 100 size. If we flatten, so it will be around say 10,000. But if we perform this sequence of and we are applying this sequentially, one convolution then one pooling, or you can add say two convolution sequence then one pooling. So this way you can perform. And there are some standard architecture, like they have tested how much convolution, how much pooling layer have can give like better result. So after that, after this flattening, you will use say one fully connected layer. So this is that we have already used in the beginning of the slides, say neural network. So that fully connected layer or say one hidden layer. After that, suppose this is your say apple versus orange classification. So then you will use say two neurons, okay, over here in the output. So here you will use say softmax and you will predict which class it is. So suppose you have one apple image. So after this learning, you will get, okay, this is with which class it is, class 0 or class 1. If it is a class 0, then it is apple. If it is class 1, this is orange. So if you are given an apple image and your output is orange, then obviously it has been misclassified. Okay, so your accuracy will fall. And I did not mention few other concepts in from the neural network, that is back propagation. You are calculating some loss, say over here loss you have calculated. So here you are learning this W, the learning parameters. You need to propagate back how much you have the loss. So in ideal scenario, your loss should be zero. So actual minus predicted, that should be zero, but it is not possible all the cases. So you will feedback this thing. So we will propagate this back, and here you need to optimize these learning parameters. For that, we need to use some optimization function. One famous optimization function is a gradient descent, and there are many variations, but in the next hour we'll through programmatically I will use say Adam optimization function. So optimization function I will use say Adam. So the mathematical formulation, if anyone is interested, you can search, or if anyone having any doubt like regarding what I am like saying, you can always welcome. You just my email ID is chandranath@iitp.ac.in. You can email me. And loss function we will use, if it is a binary classification, we will use binary cross entropy, or if it is a multi-class classification, we will use a cross entropy. So my target is to show you one example using 10 class classification, and if time permits, means like 10 class means suppose you have say 10 types of images. So you have in beginning of this class I told you the example, say apple versus orange, so two class, that we say binary classification. So for that we will use binary cross entropy. So this cross entropy, the formula is minus of y log y hat. So based on all the samples, so it will be say over I. So yi log y hat. So you have say 1,000 training samples. So for individually you will calculate and say sum it over, and after overall cost function, you will average this thing. Okay? So optimization function we will use Adam. Loss function we will use cross entropy or binary cross entropy based on the number of classes. And for the performance measure, so this is also important. That is for the performance measure, we will use the accuracy. So accuracy, I believe everyone knows. Like say suppose say out of say 100 samples, suppose my model have correctly classified say 90 samples, so accuracy will be 90%. But there are few more details in calculating the accuracy, but in short, okay, please. Okay then, so let's take 5-10 minutes break. Let's say 10 minutes break. Okay, after 10 minutes we will meet. Okay.
Thank you, sir. Thank you very much for your valuable words. Now, the participants can come up with your questions if you have any. Any query? Now, sir, thank you very much for your valuable session, and you will continue after 10 minutes.